I'm Amy Musser. I'm a certified HERS rater. HERS stands for Home Energy Rating System. And what my company does is we perform third-party inspections and certifications for homes to participate in a bunch of different above code programs. So, and a couple of examples of above code programs that a lot of people locally have heard of are Energy Star, which is an energy focused federal program for efficient homes. And another one is Greenbuilt Homes, which is a North Carolina statewide program for homes that are built with green features. We also do a couple of national green building programs called Lead for Homes, and the National Association for Home Builders has their own green certification that we also sometimes do.
Okay, so what is so I guess one thing that we are working on is trying to encourage our clients to use the energy rater. And so I actually added that into my cost code items and into our selection sheet. So it gives them the option of working with Amy right away, early in the process. And we take the energy model that Amy builds and evaluate what we're putting into the home. And then Amy will make suggestions of how to make the home more energy efficient based on what categories or what certifications the buyer wants to pursue.
Yeah, so for all of the certifications, the HERS rating kind of is the energy backbone of your certification. And the HERS rating has several parts. One part is we build a computer energy model of your house that compares the house that you're building to the same house if it were built to approximately a code minimum standard. So you get this score for your house, which I'll show you in a minute. So we built this energy model, but then we also visit the site at least 2 and usually 3 times during construction. So we see the insulation go into the house and we actually give it a grade. And if it's not installed pretty close to perfectly, we'll actually have the installer come back out and make some adjustments. So we see what happens and we go back and we update this energy model. And then when the house is all done, we actually do a bunch of tests on the house. We use a big fan called a blower door to test the air tightness of the house. And we use a smaller fan to test the air tightness of the ductwork. We'll test the bath fans and the kitchen fan to make sure that they work right. And then depending on the program that you're doing, sometimes there are a few other tests that we might do. All of that goes back into that energy model so that by the time you're done, we have this energy model that really has been tuned to how your house has been built. And it actually gives a pretty reliable prediction of its energy performance with a typical user living in the house. And it's good enough that actually banks will use it as part of their formula for appraisals and for mortgages. So that's kind of a big deal. I'm going to share my screen with you. Hang on. Sorry. Okay. Oops, cancel. Share screen. Okay, I'm going to share my screen with you and just show you a sample home energy rating certificate. So for any home that gets a HERS rating, you get this certificate when it's all completed, and it shows you your HERS score. So in this case, the house got a 66. And if you look down at this little index chart, you can see that a zero energy home, that would be a net zero energy home. That would be a home that produced, using usually solar panels on the roof, produced as much energy as it used, would score 0. And what they call the reference home scores about 100. The reference home is a house that is approximately built to the 2006 energy code. which in North Carolina hasn't really changed a lot since then. So a code built home would be about 100. And then existing homes that are older, that might have been built to older, not as good energy codes, or maybe have developed problems throughout their life, those would have a higher HERS index. So the higher the HERS index, the more energy the home uses. The lower the index, the less energy the home uses. And the energy use in the HERS index includes pretty much anything that's permanent to your house that uses energy. So it includes major appliances like the refrigerator, the washer dryer, the dishwasher, your lighting if you have LED lighting. It includes heating and cooling, which is determined by how much insulation you have and by how efficient your heating and cooling equipment is, also how good your windows are, how airtight your house is. It includes your hot water heater and how efficient that is. So pretty much everything in your house, and you can kind of see under the home feature summary some of the things that are included. Everything in your house is cataloged, and it all feeds into this HERS index. So this home scored a 66, which is a very good rating. I tend to find that the stuff that a builder can control, the heating and cooling equipment, how well insulated and airtight the house is, all of those things can get you down to about a HERS index of 55. And once you get below 55, you're really looking at mostly lighting and appliance usage. And you really can't offset very much of that until you start to put on solar. So I have seen homes without solar go as low as the low 40s. But in general, 55 is about how low you can go before you start putting solar on a house. So you can see this house scored very well. Generally, an Energy Star house will be under about 75 or 80. The annual savings is compared to an average U.S. home. So that would probably be a home in the HERS 130, 140 range. So you can see that the annual dollar savings in your bills is pretty substantial. And this really is just a certificate that kind of goes with the home to show what energy saving features it has. There are a lot of other optional reports that I can run that sometimes help us with making the house better. So I'll just show you this one real quickly. This one shows by end use how much energy we're consuming from natural gas and electricity. So one of the things that's really great about this report is you can see there's this total electricity kilowatt hours. If I give that number to the solar installer, they can then use that to figure out how much solar they want to put on a house to make it be a net zero energy house for electricity.
Amy?
Yes.
What's the average green belt score if a certification for a green belt program for the green belt?
The scores for the green belt program average similarly to Energy Star in terms of the HERS index.
Okay.
Because Greenbuilt is a green building program that includes more than just energy. So Greenbuilt has a bunch of categories that are related to different aspects of building green. So an example is water efficiency. There's energy efficiency, there's indoor air quality, there's site sustainability. So a site might be sustainable because it's downtown and it's very walkable and it's very small. So you're having a small footprint. Or a site might be sustainable because it's more rural, but you haven't disturb the site very much. And where you have disturbed the site, you do things that are impermeable so that rain will run off. You don't do a lot of paving. And the things that you plant are local or pest resistant or drought resistant so that you don't need to water them, or possibly edible because that has other benefits to people. So and then another category, for example, would be materials. So if you have a material that is low embodied energy, or recycled or produced locally, that would be considered a green material. So within green built, this HERS score is really the energy piece. So green built homes, for their energy piece, have to at least meet the same level that Energy Star would reach, or there's also a North Carolina code plus compliance path called HERO. You're allowed to do HERO, but it's very similar to Energy Star. So typically for energy, Greenbuilt homes are comparable to Energy Star homes. It's just that Greenbuilt adds all of those other categories. And homeowners differ. You know, some people, when they think about building green, really, really care about indoor air quality. That's the most important thing to them. Some people really care about having green materials. Some people care more about water efficiency. So the nice thing about Greenbuilt is it has a series of prerequisites that touch on all of those categories that says, you have to at least do these things to consider your home green. So, you know, I think we would all agree that you have to have a basic level of energy efficiency that's better than average if you want to consider your home green. And some people who build green homes will go above and beyond and do a net zero energy home or something like that. And they'll get extra points for doing that. But there's a basic level of energy efficiency that every green built home has to have. So, and then when we think about indoor air quality, in the Greenbuilt program, we have prerequisites, which are things that any green home really ought to do, because we don't want a green home to have bad indoor air quality. But not every green home has to take every possible indoor air quality step. So we have a series of points that you can get for things that you do to enhance indoor air quality. So as a homeowner, one useful way to think about the Greenbuilt Homes program is that it really provides an expert foundation of a really comprehensive list of all the green building techniques that you might want to consider using. And it kind of lays those all out, and experts have spent a lot of time developing this checklist of points. So it lays out all of the things that you might do so that you can select the ones you want to do. And then it also engages a third party to actually go to the site and see what you're doing and verify that those things actually happened. So Greenbuilt Homes is a very builder and homeowner friendly sort of way to make sure that happens. And it really all builds off this HERS index, where we're building this energy model of your house and we're going to the site and making sure that certain basic follow-through steps have happened. And we're testing the house so that we have a lot of confidence that we know what its actual performance is. We know how airtight the house is before it's turned over to you.
Very nice. So tell me about what some of the common issues you're seeing when people bring you a set of plans and ask you to do an energy model. What's something typical an assumption that people make that you find to be problematic?
So when somebody brings me a set of plans, the first thing I do is I kind of start from bottom to top. And we'll go through what you were planning to do for insulating each piece, or what we were planning to purchase for equipment for each piece. And then that'll give me a basis to talk to them about, here's where you are relative to this above code program that I'm trying to produce. And sometimes there are good reasons to be a little bit behind in one area. And as long as we make that up in another area, It's okay. And sometimes there are things that people just haven't thought about, but that could be a big problem, and we're able to catch it. So, examples of things that we often have to have a talk with people about are slab insulation. So, insulating a slab on either a conditioned basement, or if you have a house that has a slab that's on grade, insulating slabs is really hard to do well. But unfortunately, it's also really important that people do it well, because you can lose a lot of heat from the slab. And that increases your heating bill, but it also can decrease your comfort, because a cold slab floor isn't fun. So I spend a lot of time talking to people about strategies to improve their slab floor insulation. Um, Another area that we often talk about is just what type of insulation to use. Because there's a lot of information out there in the marketplace, and a lot of it is sort of true, but not entirely true. And there are different products that work better for different types of construction. So you might be looking at fiberglass or cellulose or rock wool or spray foam. And I just talk through with people, when can each product work well, and what are the pitfalls of using each product? So, for instance, if you use spray foam is self-sealing. In addition to being an insulator, it will also air seal the home to some degree. And for certain home designs, that ends up being really important, because they can be really hard to air seal if you use other insulation. It's always possible to use other insulation, and if we do, then there are additional steps that we have to be ready to take. So I can pretty much make any insulation product work. It's just, given your design and the product, what are the steps we have to take to make sure that it will actually perform as intended. And sometimes as we talk it through, we realize that for a certain house, it's going to be way easier if we use this one insulation product. Whereas for another house, we might discover that it would be just fine if we used a slightly cheaper insulation product, because that house's structure is going to be pretty friendly to that product working well. So that's something we talk through. Windows are something that I'm often talking to people about. There's so much choice in terms of windows and what glass you get in your windows. And a simple selection of a different type of glass can sometimes drop the size of your air conditioning system by a ton or even more. So sometimes, and often the glass selection isn't very expensive as a thing to change. So sometimes by making a relatively inexpensive change in terms of which glass you get in your windows, I can save you an offsetting amount of money, or potentially even more, on your heating system or your cooling system. So that's one that we talk about a lot.
Plus, you've helped us on a couple of passive solar projects where the glazing requirements were very unique, and we had to understand that going into the project.
Yes, especially for passive solar, the way the building code is written, to use the higher solar gain windows, you actually have to have an engineer or architect do an analysis and stamp it. And you definitely have to do that up front, so that you know that you have a plan for your higher gain windows on one side, and then an appropriate number on the other side of the house, and that the whole package still meets the building code. So that's a really important thing to do before you buy windows.
Yeah, one thing I get a lot of customers that want passive solar. They don't understand how it impacts the rest of their home. And we've had some projects where they had, some type of geothermal and maybe some hydronic floor heat. And then when you try to mix in passive solar to too many variables, if there's tubes in the floor, it just doesn't go well.
It can be okay. I actually live in a house that's passive solar, and I do have radiant floor heat. But it isn't always necessary to do both. I think, if I went back, I probably didn't need the radiant floor heat, because my passive solar keeps my floor warm. But you definitely want to talk to somebody who's familiar with passive solar, because you can get hot spots. If you get a really sunny day in February, you might be opening some windows to cool your house down. So it's not for everybody, but if you really would enjoy wearing shorts in your house on a sunny February day, it's definitely for you.
Yeah. Well, I have to say your slab insulation diagrams that you sent us and the information, we're able to take that back to our contractors and to our field managers and talk that process through to make sure that moving forward we have a better process in place.
Oh, that's great.
Yeah, and it's easy with those diagrams to when we issue a purchase order to require them to execute it a certain way. So I appreciate that. What are some of the common things that you're seeing on job sites when you guys are coming out at 3 different points? So I want to maybe take a second and hear about some common issues that you're seeing and some of the things that having you on the team on the project brings value to the client.
Yeah, so my husband, I has this way of describing what we do that I think is like a really, really great way to describe it. So he says that, if you were buying a car and you had somebody that was really knowledgeable about cars who could look at the car before you bought it, and go under the hood and knew what they were looking at and say, okay, this looks good. This might be a problem. You should get this fixed. Most people would do that, especially if the cost was a pretty small percentage of the car's cost. And that's really how we think about what we do. So we come out on site 3 times, typically. The first time we come is around when the house is framed, around when you're putting the windows in. And honestly, the major purpose of that first trip isn't to look for problems, but it's to look for difficult areas to insulate and make sure that we have a plan. Because sometimes when we look at your building plans, all of the little details of how things will be framed aren't always obvious. And sometimes once it's up, we'll see something where we say, oh, that's going to be really tricky to do. Let's develop a plan for that. So it's easy when we walk through at framing to see, oh, here's something that's going to be hard to insulate. Let's make sure we know. So sometimes we'll switch a little area to spray foam because spray foam is going to work better for us. Or sometimes if something like if a wall's framed really thick in one location for some reason, we'll increase that wall to like an R30 batt instead of an R19 batt. So we want to talk through all those things so that people have the insulators on board, knowing what their scope of work is, and so that when they come to the job site, they bring all the materials they need. One thing that I discover a lot at framing inspections is if people have can lights in a vaulted ceiling, you've got to have a certain amount of insulation above the can light so that you don't just have this hole in your insulation where that recessed light is. So if you have can lights in a vaulted ceiling and there isn't very much space behind them, they might have to actually bring a more dense type of insulation. Usually it will be a rigid board insulation to cut and put behind those can lights. So we want to discover that before the insulator gets started so that we can give them a list of here's all your tricky stuff to do. Make sure you bring the right materials and make sure you phase your crew in a way that they, the person who goes and puts the rigid insulation behind the recessed lights needs to do that before the rest of the ceiling gets insulated. So really at the framing inspection, I am checking to make sure that you haven't used too much framing that would displace insulation. And I'm making sure that you use the right windows. Another thing I found, especially in those passive solar houses, is sometimes if you have the same size window on your south side and your other sides, I've had times when people put the south window on the west side and the west window on the south side. And you definitely do not want to do that. So we're coming early so we can catch those things and they can get fixed. So that then when I come back for my insulation inspection, which is my second trip, I'm hoping that it'll be a really smooth trip where everything is just the way that I expect it to happen. And the way that my inspection for insulation is a little bit different from the code inspector is the code inspector is predominantly just looking to see that an insulation product is there, and that, you know, it has the right R value. I'm also looking, I'm grading how well it's installed. So with me, neatness counts. So especially with your fiberglass insulations or your fibrous insulations like cellulose, neatness is really important. So we want to make sure that it's filling the whole wall cavity from front to back, that it's not compressed behind anything. They would, if there's a wire in the middle of your wall, they would actually cut the bat and split it around the wire. If it's cellulose or a blown product of some kind, usually they'll put up a net and they'll blow the insulation in, and we want to see that it's really tight behind that net so that it's not going to settle down over time and give you these gaps at the tops of your walls. With spray foam insulation, we're looking, so they spray the foam on and it's never perfectly flat, but we want to make sure that it's, you know, there aren't too many low spots, and there aren't too many bubbles. Sometimes when it's cold outside, spray foam insulation can start to peel off your structural members, so you get some peel back, and that can give you some gaps. So we want to make sure that that didn't happen, or if it did, we want to make sure that those gaps get filled back in. So we're really looking for consistency and neatness, and that nothing has gotten missed. So we want to be able to connect floor insulation to wall insulation to roof insulation, so that I can just draw a line around that house and it's continuously insulated. So then our final visit is when the house is all done. And that's when we come and we do our blower door test, where we test the air tightness of the house. We test the air tightness of the ductwork. And, you know, generally in the previous visits, I've been looking at these things, and I have a visual checklist of air sealing that you have to do. So, you know, we don't get that many failures, because if people are taking us seriously as we go through that checklist, then when we get to the end, we should get a nice tight result. You know, sometimes we don't, and that's when we start to go back and investigate. One good example of when that happened was I had a house that had a big attic, and the attic kind of connected to the top part of the garage. And it turned out the cable guy had come, and when he was trying to run the cable into the house, he just punched this giant hole between like the above garage to the attic of the house. And since it was the attic, nobody went up there to look at it to see what he'd done. So when our blower door test was kind of bad, we started to look around, and we figured out that the cable guy punched this big hole. So, you know, really the air tightness testing is almost just a confirming that you've done your job. But then it's also a way that helps us find the problem if we don't get the test result that we want.